Point one, the key ideas here that you see in your textbook, we've talked about most of this already. Okay, the solutions to a quadratic equation would be the same as the x-intercepts or the roots or the zeros. There are some equations though where there are no solutions. So if we have a parabola that does not have any x-intercepts, there would be no solution. So think about this: if we have a parabola or a quadratic expression that equals 0, and there are no x values that cause the corresponding function to hit the x-axis, then there are no solutions. And that would happen when you have, an equation that has an expression for a parabola that looks like this. Over here in the next one, if it touches the x-axis at one place only, that is the vertex is on the x-axis, then there's exactly one solution to this equation. And if the parabola intercepts the x-axis twice, then there are two real solutions, and they're different. Now, 2 is the maximum number of solutions you can have for a quadratic, just 2. Because in a parabola, that graph would only be able to touch the x-axis maximum 2 times. So it could be 0, 1, or 2 solutions. So I asked you to get a start on questions 1. I think I just said question 1, but I wanted you to take a look at question 2 as well. But in question 1 it says, how many x-intercepts does each quadratic function graph have? Well, here it appears that this graph touches the x-axis at one spot, and so there would be one solution here. And it looks like the solution would be x equals 0. So if we have y equals x squared, where does y equal 0? Well, when x is 0, because 0 squared is 0. Okay, that would be the solution to the equation. For the next one here, and I'll just clip this out so I can draw and write on this. So, all right, so going back into start a notebook here. So what are the solutions here? So everyone watch this. This is a bit of a summary of what we've learned so far, but also going forward. So the solutions to the corresponding equation, well, there's no constant over here, right? And so if you let this equal 0, this is the corresponding equation. So for this graph, this is the equation that you can solve. And this equation can be solved by looking at where the intercepts are. And it looks like x equals -4 and -1. Those appear to be the intercepts. Now we could check that, and let's just do that. So -4 squared minus 5 times -4 minus 4, that should equal 0 if we've got this correct. So what does this look like? Well, that's -4 squared is positive 16, so that's a negative 16. This is a negative times a negative, so that's plus 20 minus 4. Okay, so negative 16 minus 4 is negative 20 plus 20 is 0. So that solution checks out. Okay, that's the solution to the equation that lets this same expression equal 0. Okay? At -1, we could check -1 real quick too. Let's do that. We input that value in as well. We see that -1 checks out. Okay? So this is how the zeros of the graph and the roots or the solutions to the corresponding equation, that's how they match up. Okay. All right. For C, there's no solutions, right? Or how many x-intercepts? 0 x-intercepts. So there's no value that will make this 0. And let me just talk about that real briefly, because this is an important connection here. And again, you weren't asked to do this in number 1, but I just want to take this opportunity to just show you this. Okay. So this is the corresponding equation here. It's 0 equals x squared plus 2x plus 4. So what value for x would give us 0? Well, here's the problem. Here's the problem. If we had a negative x value, let's pick any negative x value, like -1. Okay, if we did -1, then this would be -1 squared minus 2, right, plus 4. That's going to give us a positive value. That's 1 minus 2 plus 4. That's a positive answer. And there is no x value that you can pick that will give you 0 or anything negative. Okay, now so 4.1 is just solving by graphing or using the graphs. So I'm not going to get into the algebra yet. But because this does not touch the x-axis at all, that means there are no solutions. So there are no x-intercepts, which means that there are no solutions, okay, to this equation right here. All right? Okay. So in question number 2, it says, what are the roots of the corresponding quadratic equations? Well, they're the same as the x-intercepts. That's all you have to do. For number 2, it's just they're the same as the x-intercepts. You rewrite the x-intercepts are the same as the solution. Okay. So solve each equation by graphing the corresponding function. In number 3 and number 4, what are the roots? So let's take a look at just one of these from, let's say, number 4. So what about this one? This one says, what are the roots of each quadratic equation? And where integral roots cannot be found, estimate the roots to the nearest tenth. Okay. So if you're doing this by hand, you have to estimate, but we'll maybe do this on our calculator, okay, or using technology. So if you have this equal to 0 here, this is very important, this has to be equal to 0 in order for you to now explore the graph, okay? So if you had like 10 over here, you can't just plug this in and look for the x-intercepts. You can't. Because the x-intercepts would be the x values that make this side equal 0. That's what the x-intercepts do. They make it equal 0. You don't want it equal 0 if it's 10. You see? So you got to get this 10 over here and combine it with this constant term, and then it equals 0. Then you graph what's left over. All right? So I'll say that just one more time, real briefly, is that you can graph it and look for the x-intercepts only when this quadratic equals 0. If it doesn't equal 0, then you have to get all of those terms over to the same side, combine the like terms, and then graph it. So this has to be 0. So with the graph here, let's see. Graphing calculator. I know you don't have them right now, but just watch just as a review here. So we're going to go to y equals. We're going to clear everything that's there, make sure the plots are not highlighted. Then we're going to type in 3x squared plus 9x minus 12. Okay? Then you're going to graph that. Just hit the graph button. So I can see that there's two spots, where the parabola hits the x-intercept. So those are going to be my solutions. And how you exactly find those with the calculator, second function trace, which is the calculate menu. Go down to number 2, hit enter. And then it's going to ask you for boundaries here. So where's my cursor? Okay, there's my cursor. So it's left of this intercept. So let's say left bound, yes. Let's go now to the right, right bound, enter. Boom, there it is. So we have an x value of -4, apparently. X equals -4. Well, what else do we have? Let's find the other intercept. Second function, calculate menu. Number 2. Let's go over to the just to the left of the intercept. Where's my cursor? It's coming. There we go. So enter. Over on the other side, enter. Hit enter one more time. Boom. X equals 1. The y is always going to be 0, right? Because it's a 0. So x equals 1, that's the one you're looking for. Those should be solutions. If we plug -4 in here, and if we plug -1 or +1 in here, it should give us 0. Okay? So that's how you use the graphing technology to solve a quadratic equation. Any questions so far? This doesn't equal 0. Let's say we had something like this. 12 equals 3x squared plus 9x. This is actually the exact same equation. Things are just moved around a bit. Okay? Girls in the back, listen please. Very, very important. This is the exact same question. It's just that the terms are moved around a little bit. The solutions for this equation are the exact same. Okay? Now, what you can do is two different things. If you have a question like this and you're asked to solve graphically, two different options. The first option is to, again, like I said earlier, move everything over to one side and let the one side, doesn't matter if it's the left or right, let it equal 0. So you see how we get this, and we've already done that up here. So that's the same. Here's the other thing that you could do. The other thing you could do is, and this is coming, so what you could do and what you'll be expected to understand is that we could actually graph two functions here. I could graph y equals 12 and I could graph y equals 3x squared plus 9x. And then I could find out where those two graphs intersect. So which x values make those two equal? That's the intersection point. Okay? So let me show you that real quick. On the calculator, we go to y equals. So what I'm going to do is I'm going to graph, instead of minus 12, right? Let's go over here. I'm just going to graph this one, and then I'm going to graph 12 down here. So let's graph that and see how that looks a little different. Now, I can't see the 12 because of my window, so I'll adjust my window. That is the y maximum. It only goes to 10. So let's make that go to like 16 or something. And we'll graph that again. So look what happens. I've got a straight line, y equals 12, and I've got a quadratic function, y equals 3x squared plus 9x. So in this method, method number 2, you graph the function, the corresponding function that shows up on the left side, and the corresponding function that shows up on the right side, and then you find out where the two meet. Now, finding the intersection point is actually easy as well. It's on the same calculate menu. See the 0? We're not finding the 0 now. Now we're finding intersect. So you hit number 5. And then the questions will be slightly different. It will say first curve. So if the cursor is on one of the curves that you've written in it, you just say yes. And then it'll automatically pop to the next equation that you've typed in. And if you only have 2, it'll just automatically go to the other one. So here's the equation up top. It'll say, is this the second curve you want me to consider? You just hit enter and say yes. Then it'll say, do you want me to guess? And so what you do is you move your cursor so it's close to the intersection point that you're looking for, and then you hit enter to say yes. And look at this. Here's the intersection point. X equals -4, y equals 12. Well, we're only considering the x values, so it looks like x is -4 is a solution. Well, it is. If we were to do that again, which I'll do that again real quick, intersect, first curve, yes, second curve, yes. Now I have to move my cursor over, so I tell the calculator I want to find this intersection point now, not the other one. Then it should quickly calculate, there you go, x equals 1. Okay? So that's another way that you can use the calculator to find solutions to a quadratic equation. Okay? So there's 2 methods there. All right, let's see if my textbook is behaving here now. Hit a maybe. Okay. My digital textbook is not working very well. Okay. So what I'm going to get you guys to do, I was going to go over maybe a word problem with you here, but I'm not sure if I will just now. But you get going on your assignment that I've given you. I'll give you some time to work on the second half of the assignment for 4.1. All right. So that's 2, 4, 6, 7, and 8, as well as number 1 that you did yesterday. So you can work on that for now, and then I'll probably maybe go over one of those questions with you in a bit. Okay, so this is number 6 from 4.1. This is not a difficult problem, and everyone listen up, please. I know that you know the answer to this. Like 2 seconds after you read it, you know what the answers are. 4 and 5, right? They add up to 9. They multiply to 20. But watch, you're going to get questions that are like this that are not going to be so easy to find, and they're not going to be integers. They're going to be decimal numbers and blah blah blah. So we need to know how to use quadratic equations to solve this. So this is another important part of this this section. Okay. So a sum of 9. We're looking for 2 numbers that have a sum of 9. So let's say x plus y have to equal 9. Now, we can't use 2 variables. We can only use 1. All right? So how do I express one number being x and the other number being something in terms of x? Well, if one number is x, like it is there, the other number, watch this, the other number y is actually 9 minus x. You see that? So these two add up to 9 when you add them. So if you have 2 numbers adding up to anything, it's one is x and the other one is that something minus x. That's always what it is. So these 2 numbers right here that are described by x and 9 minus x, those 2 numbers add up to 9. Check. We also need to show that there's a product of 20, so they multiply together to equal 20. So how do I show that? Well, I go this. I go x times 9 minus x equals 20. And boom, now you have your equation. That's a quadratic because you're going to go, when you expand this, it's 9x minus x squared equals 20. You see that? So this actually turns into 0 equals x squared minus 9x plus 20. Now you know how to solve this. So the word problems sometimes are going to ask you to create the equation given the information. All right? So now then you go ahead and you would solve for the zeros of this, and those would be your answers. The x-intercepts of this function right here, y equals x squared minus 9x plus 20, those x-intercepts will be your solutions to this problem. Okay? Questions about that? I'll let you finish that on your own, but you'll find that those intercepts should be 4 and 5.